ROC Curve in Model Evaluation. AI Beginner Level. Introduction. When evaluating machine learning classification models, it is important to measure how well the model distinguishes between classes. One powerful evaluation tool used for this purpose is the ROC curve, Receiver Operating Characteristic Curve. The ROC curve helps analyze how well a model can separate positive and negative classes at different classification thresholds. ROC curves are widely used in AI applications such as medical diagnosis, fraud detection, credit risk analysis, spam detection, security systems. Understanding ROC curves helps developers evaluate classification models more effectively. What is an ROC curve? An ROC curve is a graph used to evaluate the performance of a classification model by plotting true positive rate, TPR, against false positive rate, FPR. In simple words, ROC curve equals graph showing how well a model distinguishes between classes. Example concept. Different classification thresholds means ROC curve means model performance. The ROC curve shows the trade-off between detecting positives and avoiding false alarms. True positive rate, TPR. The true positive rate measures how many actual positive cases are correctly identified. It is also called recall or sensitivity. TPR equals frac, true positives plus false negatives. Example concept. Actual positives means correctly predicted positives means TPR. A higher TPR means the model detects more positive cases. False positive rate, FPR. The false positive rate measures how many negative cases are incorrectly classified as positive. FPR equals frac, false positives plus true negatives. Example concept. Actual negatives means incorrectly predicted positives means FPR. A lower FPR means the model produces fewer false alarms. ROC curve graph. The ROC curve plots true positive rate, TPR, on the vertical axis, false positive rate, FPR, on the horizontal axis. Example concept. FPR, x-axis, versus TPR, y-axis. Means ROC curve. Each point on the curve represents a different classification threshold. Ideal ROC curve. An ideal machine learning model has a curve that moves toward the top left corner of the graph. Example concept. Perfect model means high TPR means low FPR. The closer the ROC curve is to the top left corner, the better the model. Random classifier. A random model produces a diagonal line. Example concept. Random guessing means diagonal ROC line. This means the model is no better than random prediction. Area under the curve, AUC. The area under the curve, AUC, measures the overall performance of the model. 0 LEC AUC LEC 1. Interpretation. AUC score meaning 1.0 perfect model, 0.9 excellent, 0.8 good, 0.7 fair, 0.5 random prediction. Example concept. Higher AUC means better classification performance. Why ROC curve is important. ROC curves provide several benefits. Evaluate model performance across thresholds. Compare different classification models. Analyze trade-offs between sensitivity and specificity. Example concept. Multiple models means ROC curves means performance comparison. Developers can select the model with the best ROC curve. Example Python code. Example ROC curve using Python. From sklearn. Metrics import ROC_curve. Example AUC calculation. From sklearn. Metrics import ROC_awk_score. Libraries such as scikit-learn allow developers to generate ROC curves easily. Real-world applications. ROC curves are widely used in AI systems. Medical diagnosis. Evaluating disease detection models. Fraud detection. Analyzing fraud detection accuracy. Credit scoring. Evaluating loan risk models. Spam detection. Comparing email filtering models. Concepts learned from ROC Curve. Understanding ROC curves helps beginners learn. Checkmark how classification models are evaluated. Checkmark how thresholds affect model performance. Checkmark how to compare machine learning models. ROC curves are an important part of model evaluation in machine learning. Simple definition. ROC Curve. A graphical evaluation tool that shows how well a classification model distinguishes between positive and negative classes. Final summary. The ROC curve is a powerful evaluation tool used in machine learning classification problems. It plots the true positive rate against the false positive rate across different classification thresholds. The area under the curve, AUC, provides a single value representing overall model performance. ROC curves help developers analyze classification models, compare algorithms, and choose the best performing model. Understanding ROC curves is an essential step in learning machine learning model evaluation and AI performance analysis.